Hi there folks, it's Mr. Rennie Evans here, and I'm going to be taking you through some of the revision work that we are working on over your Christmas holidays in preparation for your FABs, which will take place in the first 2 weeks back after the holiday. So what we're going to look through here are some exam style questions which in particular have been picked out as ones which across our kind of block 1 and block 2 assessments the most mistakes were coming from. So just to highlight a few key points in particular from these areas that you can see. So we're going to be focusing in on double angle formula from trig, perpendicular gradients from straight line, a couple of wee vectors bits, and some work on graphs of functions as well. Now obviously this might not be relevant to everybody, and I'll show you at the end of the video where you can go to look for some more support. So if these are not going to be relevant to you, then you can skip on towards the end of the video and I'll be discussing where else you can go for some further questions. Okay, so let's get started on this first question here, which is a double angle formulae question, and I'm going to need to try and fiddle about with PowerPoint. There we go. So here we are given tan of 2x is equal to 3 over 4, and we're working in the interval of between 0 and pi over 4 radians, which is the same as 90 degrees. So I'm just going to pop that in just now, just so I've got it in my head. And we are wanting to find out the exact value of cos 2x and then go on to find the exact value of cos x. Okay, so first of all, remember anytime that you are faced with a question that looks something like this to start off with, we're probably always going to be best off drawing an exact value triangle. So I'm just going to sketch a wee exact value triangle up here. The angle at the center is going to be 2x, so just remember that. It's a right angle triangle, and because we know that tan of 2x is 3 over 4, remember that tan is opposite over adjacent when we're thinking about our SOHCAHTOA. So opposite, we are looking at this side here being 3 and adjacent being 4. Now you can work with Pythagoras here if you would like to, but what you might also remember is this is a Pythagorean triple, so it's a 3, 4, 5 triangle. So that helps us really quickly for 1 mark in question A, get the exact value of cos 2x, because if we remember, I'll just write out SOHCAHTOA. If I want to find the exact value of cos, I'm doing adjacent over hypotenuse, and in this case, my adjacent would be 4, my hypotenuse would be 5, so the exact value here is 4 over 5, and that would get you 1 mark there. Okay, now for part B here, we're just wanting to look for cos x. Now what we're going to do here is we want to go and use our formula sheet to find out what expressions we know are equal to cos of 2x. And we're looking for the one in particular that just contains cos of x by itself. So I'm just going to show you just now, your formula sheet would be here. And we're wanting to go down and look at the trig function section here, or the trig formulae. Now, we know that there's a couple of different ways that we can express cos of 2a, just looking at kind of this 4th row down here. So we've got cos squared a minus sine squared a and your other 2 versions. Now we can see there that 2 cos squared a minus 1 is the version that only has cos in it. So we're going to say, oops, that's quite big. Let's just try that again. Yeah, there we go. We know that cos of 2x can be expressed as 2 cos squared x minus 1. So let's substitute in that I know I've got 4 over 5 here as a possible answer. And then I'm basically just wanting to go and rearrange this equation here until I get cos of x by itself. Okay, so let's do that just now. I'm going to add 1 onto both sides, and working in fifths, 1 is equal to 5 fifths, so that's going to be 9 over 5. Is equal to 2 cos 2x, 2 cos squared x even, God. And then I'm going to divide both sides by 2, just fling my working up here. So that's going to be 9 over 10 is equal to cos squared x. And remember, all that really means is that means the exact same as cos x squared. So if I want to get cos x by itself now, I'm going to need to square root both sides. So that's going to be equal to the square root of 9 over 10. And let's just, for talking sake, finish this off as 3 over root 10 just there. Okay, and that would be our first question done. Okay, so going on to the second question here, we've got an equation that uses the double angle formulae. And again, we're going to jump back over and check our formula sheet in a second. So just now, I've got cos of 2x equals 5 cos of x minus 3. I'm working in degrees, and I know that my answer could be anywhere between 0 and 360. Now remember, it can be including 0, but it can't include 360, okay, just from the way that the inequality symbols are set up there. Okay, so let's rearrange this formula. Now I'm going to, again, substitute in for cos of 2x for one of the values, and you can see here on the right-hand side that I only have cos's, so I'm just going to sub in that same one that I used for the first question, so I don't have any sines involved in the question. Okay, I'm going to collect everything over onto the left-hand side now, so I'm going to do my opposite operations. Okay, and that's going to give me 2 cos squared x minus 5 cos x plus 2 equals 0. Okay, now what I do here is I kind of go off to the side and I'm almost just going to rewrite this equation, because really what it is, it's a trinomial, but I'm just going to rewrite it just using c's. Okay, so it becomes a bit easier for me to spot what it is I'm actually doing here, and I want to try and factorize this expression because it is a trinomial. Okay, so I'm going to start off, I've got a 2c and a c as the start of my brackets, and I'm looking for terms which will multiply together to give me positive 2, but will add or subtract together to give me negative 5 once one of them has been times by 2. Okay, so let's just start off with our possibilities here. We know that 2 negatives or 2 positives are the only 2 things that can multiply together to give me a positive. So I know that I've either got 2 positives or 2 negatives, but I also have a negative in the middle, and there's no way for me to add 2 positive numbers together and end up with a positive number. So I'm going to need to use 2 negatives, so something like minus 2 and minus 1. And what I can do once I think I've got them set up is I'm going to multiply diagonally. Okay, so 2c times by negative 2 is going to give me minus 4c. C times by minus 1 is going to give me minus c. Let's check, what do they add together to give me? Well, they add together to give me minus 5c, so I know that that works. So in this case, I'm factorizing this to give me 2c minus 1 and c minus 2. Okay, if you want to use a different method of factorizing, that's absolutely fine. Okay, now remember, all we're going to do here is that this now becomes my solution back over here. So that's going to be substituting in that I'm going to write cos instead of just the letter c. 2 cos x minus 1 bracket cos x minus 2 equals 0. Okay, so let's start to solve these. Remember, I'm going to need to split these up. So 2 cos x minus 1 equals 0. Cos of x minus 2 equals 0. Work with your equations. So that's going to end up being cos of x is equal to 1/2. And cos of x is equal to 2. Now, hopefully you can remember here that just from the cos graph, if I'm just working with cos of x, my maximum is 1. So if I've got a 2, I can see here that I would have no solution. Okay, so that is basically going to become invalid. I get no solution there. Okay. Whereas in this section here, I'm going to get x is equal to the inverse cos of 1/2. And what you can probably remember from your exact values, or hopefully from your exact value triangle, let's just draw it out here, that if I've got 30 and 60, they should maybe be in the other way around about, but oh well. We should look for something like this. So my exact value, first of all, for the inverse cos of 1/2, well, I get that cos being adjacent over hypotenuse when I use 60 degrees. So 60 is going to be one of my solutions, and I'm also going to need to find another solution. Okay, so I'm going to go over here and I'm going to just squeeze that in. So this is where we would map out our cast diagram. Say that we are looking for, well, I've got a positive half that's going in, so it's all in the cos quadrant. I've got 60 up here. I know that I would need to do 360, take away my related angle, which would be 60. That's going to give me 300. So my solution, if I just squeeze it in there, is going to be 60 and 300. Okay? Right, let's go on to our next question then. Okay, our next question here is about perpendicular gradients, okay? We want to determine the equation of the line perpendicular to 5x plus 2y equals 7, and it's passing through the point minus 1, 6, okay? So if I'm looking for an equation, particularly of a straight line, I'm going to split it up into 3 parts. I'm looking for my gradient. I'm looking for my point. And then I want to go on and find my equation. Okay, so let's start off with our gradient. Well, What we know so far is that the gradients are perpendicular. And if we remember, if two gradients are perpendicular, it means when we multiply them together, we're going to get -1, okay? So I want to rearrange this function here into the form y equals mx plus c. Really important that it is in that form, because that is going to let you find out what the gradient of this expression here is, okay? So in this straight line, the gradient was -5/2, okay? Now, as they are perpendicular, that tells me that the perpendicular gradient is going to need to be, and remember our wee cheat that we do is we can basically flip it upside down and multiply by -1 or divide by -1, if you want to think about it that way, okay? But we change the sign and we turn it upside down, so we know the gradient of that line is going to be 2/5, the one that we're working with. And we also already know that the point is -1,6. That's going to be our AB. So I just go into my nat5 formula, y minus b equals m bracket x minus a. So I've got y minus 6 is equal to 2/5 of x plus 1. Remember, your minus and minus becomes a positive. I'm going to multiply all of my terms. Now just remember, your terms are your individual things, not anything that is inside a bracket. By the denominator of the fraction, I'm going to get 5y minus 30, expand my bracket, I'll get 2x plus 2, and then let's just make y the subject of the formula. And remember, you don't necessarily need to get y by itself, okay? So something like 5y is equal to 2x plus 32 is absolutely fine, because at higher, we're just looking really to know, do you know how to find the equation of this, not express it in what might be described as its simplest form, okay? So we're all good there for our 3 marks, okay? Let's move on to our next question then. Okay, here we've got a vectors question. So part A is to show that you've got 3 vectors that are collinear. And remember, what we want to do here is we basically want to show that the vector that joins these 2 points together and the vector that joins these 2 points together are scalar multiples of each other. Okay, now once we do that, we're going to basically say that that makes them parallel, which means that they are kind of following the same path, so they could look something like this. But if they have got a shared point, that means that although that they're following the same slope, well, that and that both can't be the same point. So that means that they end up looking something like this, and they end up being collinear. Okay, so let's work through this question then. So we want to find the vector that joins A to B. So it's going to be B minus A. Okay, let's go into a column vector here. So 4 minus 1, 0, minus 1, 5, minus 3. Just be careful with your negatives here. This is kind of where most people trip up. So that's going to give me 3 minus 6, 3. So I almost tripped myself up there as well. Okay, and now we're going to go from B to C. So that's going to be C minus B. So that's 8, negative 9, 4, minus 4, negative 1, 0. That's going to be 12, where am I? Minus 8, 4. Okay, so now I need to kind of say why or how are these related to each other? Well, what you might be able to notice is that vector BC is equal to, if I were to take vector AB, divide it by 3 and then times it by 4, so it's equal to 4/3 of vector AB. Now, there's lots of different ways that you could explain that, okay? You could also say that 4 times AB is equal to 3BC, or you could say something like AB. Oh, I don't know why my pen keeps going bold. What am I saying? That is equal to 3/4 of BC. Okay, so there's a couple of different ways that you could describe it. Okay, any of these would be enough for you to say basically that you have got a you're showing that they're scalar multiples of each other, so therefore they are parallel. And then you would say as B is a common point, A, B, C are collinear. Okay. Now, from there, what we're going to do is we want to go on and do part B, which is asking you to state the ratio in which B divides AC. Okay. So what that's asking you to do, if I were to just do a wee sketch here of like our A, our B, and our C, that they look something like this. So A and C, we already know that that is one line, and we want to know how does B split up, okay? So what we're going to start doing is we're going to investigate our x ordinates only, okay? So if we're just looking at x's only, we are at 1 on the x-axis when we're at point A, we are at 4 on the x-axis when we're at point B, and then we are at 8 on the x-axis when we're at point C, okay? So I want to think, how far have I went to go from 1 to 4? Well, I went forward by 3, and then from B to C, from 4 to 8, I went forward by 4. So therefore, if I'm thinking about what the ratio of A to B to C is, that's going to be the ratio 3 to 4. And you would try and simplify there if you could, but we can't do it in that case, okay? And if you're not 100% sure, you could also go and check that with your y-axis or your z-axis as well, just to make sure that you are really happy with what has happened, okay? And you can check that for yourself, but you'll get the same answer. All right, okay, and that's question 4. Okay, question 5 here is a perpendicular vectors question, okay? So what we're going to do is, you can see here that these are set up in a slightly different format. So let's set these vectors up as column vectors first. So U would be 8, 2, minus 1, and V is going to be minus 3, T, 6. Okay, so we've got a missing coefficient here in vector V. We know that these vectors are perpendicular, and we want to determine the value of T. Okay, so if two vectors are perpendicular, it means that their scalar product is equal to 0. Now, there's a couple of ways we can look for scalar product. I'm going to just take you back to the formula sheet for a second. Okay, and if we look up here in the scalar product section, you can see that you've got two methods here. Either A dot B is equal to the magnitude of A times the magnitude of B times the cosine of theta, where theta is the angle between the two vectors, or we can basically take the components and multiply our matching components. So you can see from that example there, for A dot B, we do A1 times B1 plus A2 times B2 times, plus A3 times B3, okay, and we sum that to get an answer. So we don't have any angles here, and we don't know the magnitude, so that means that we're going to need to go for our kind of perpendicular proof here, by taking the components, so kind of our x components, our y components, and our z components, we're going to multiply them together and add them all. So that's going to look like this. We're going to do 8 times by minus 3 plus 2 times by t plus minus 1 times by 6. Okay, so that's going to give us negative 24 plus 2t minus 6. And let's collect our like terms. So we're just going to do this little subtraction that I can see here. We're going to get 2t minus 30. And now I just want to solve, because we're basically being told that they are perpendicular. So we know that that is true. So that means that we can use this fact to solve here. So 2t is going to be equal to 30. And then I'm just going to come over here, dividing both sides. We're going to get t is equal to 15 for that to be true. Okay, so that's actually quite a nice wee scalar product question there, but it comes from this fact that we need to remember, that for perpendicular vectors, their scalar product is equal to 0. So that's a wee fact that we need to remember. Okay, on to question 6. We've got a transformation of a graphs of functions question here. Now, there's two transformations that have happened. So what I'm going to do is I'm going to start off with a wee table of values, okay? I want to, now you would be given a wee diagram to use here, okay? But from the graph that I've got here, let's seek out our important point. So I know that I've got an important point in the graph of f of x, or what's it called, h of x. So let's just change that to an h, okay? In h of x, I've got an important point at 5, 0. I've got a turning point. And then I've got another point at 2, 2. I'm talking nonsense. That's not the 0.50. Sorry, I just noticed that there. Let's fix that. Because, of course, that is actually the 0.05 numpty. Okay, so from there, that is our important points in the graph h of x. So we're going to explore these transformations here. Now, I want you to remember we're going to follow the order of operations. So, first of all, if I see a negative stuck in front, then that negative is multiplying these, which means that that's going to be our first thing that we need to do, okay? So if there's a negative in front, think about what number that's actually being multiplied by. It's being multiplied by the number -1. And outside of this bracket means that we're going to be affecting our y ordinates. So that -1 that we're multiplying the function by is actually going to take our y ordinates and multiply each of them by -1. And what we sometimes think about that as we have reflected the graph in the x-axis, okay? So it's going to look upside down, which means that already we know it's going to follow kind of the opposite of this. So it's going to look something like that, okay? So that's the sketch that we've got in our brains. Okay, the next thing that I want to do is deal with this 2 here, okay? Now this 2 is sitting in front of the minus, but remember that is a positive 2. So what that means is it's outside the bracket, we're adding on that 2, so it's still going to affect our y-axis, but it's going to move all of our y-coordinates up by 2 units. So let's look at this. I get 0, -3, and 2, 0. Which means on the graph that you would have to sketch this on, we are dealing with something in this shape with these important points, okay? So let's plot where 0, -3 might be. That's down here. That's 0, -3. Put in that's my y-axis, that's my x-axis. And I've also got 2, 0, so that lies on the graph, okay? And that is also, remember, this point of inflection here, which upside down is going to be here, this increasing or rising point of inflection. So we're going to come down to our now minimum turning point at 0, -3. We're going to go up. My graph's maybe a wee bit too wide, but let's just try and make it work, okay, to our point of inflection here. And then our graph is going to increase after that, okay? Now, what we would want to do is maybe have this a little bit more to scale so that this very clearly looks like a rising point of inflection. But I'd like to think that the SQA would be nice enough to give that there. And forgive me for my wonky graph. Okay, last question then that we're going to explore is actually this same graph, but the part B asks you to sketch the graph of the derived function. So y equals h dash of x. Okay, now, let me just sketch out this graph again. Now remember, when we're working with derived functions, we're basically thinking about having differentiated this, okay? So we've got a quartic just now, okay? And it's got 1, 2 turning points that we can see, okay? But with this one being a falling point of inflection, we need to keep a wee eye out on that, okay? Now what we're going to do here is we're going to take each of the points where we see a turning point, and these are going to go down onto the graph and they're going to become roots, okay? So we know that we've got a root here. Now just be careful. I know there's a 5 involved there, but it is the point 0, 0. And this one here, again, is going to drop down and become the point 2, 0. So we're basically ignoring what we've done already in the previous question, okay? So that was a completely separate part A. This part B is separate. So based on this graph here, remember when we're working with the graphs of derived function, we now start investigating the graph from left to right. If, as we approach our first stationary point, the graph goes up from left to right, then we know that that is increasing, which means that when we derive it, we're just going to get a positive value. Now that positive value is basically meaning that it sits above the x-axis, okay? Which means that it doesn't really matter the fact that it looks like it is coming up from below the axes here. We just know that we need positive values, which means it is above the x-axis in our derived graph. Now we look at what is happening between the 2 points, okay? So my graph is decreasing between the 2 stationary points, and when we're decreasing, we draw our line under the axis, so we need to connect these 2 together. And then you can also see after the point of inflection, we're decreasing again. Now, what that means for us on the derived graph is that we're going to need to go down again, okay? We're going to need to stay under the x-axis. So this point here actually becomes a turning point, and we need to make it very clear that we are decreasing again, okay? So an even better sketch would be to make sure that we knew that beforehand and make it a nice, clean turning point, okay? And I'll take out this little bit that we've got in here, okay? Perfect, that'll do. Okay, and that gives us our graph of our derived function. Okay, now that's all the key questions that we wanted to look through, and you can go away and you can find some similar questions to practice based on these, but I feel like these are the really key points that we want to make sure that we've hammered home and we get really comfortable with. okay? Now, your next steps, what should you be doing? The best way for you to revise for maths, particularly at higher, is going to be to complete past papers. Now, we've used the website Free Higher Maths quite extensively during class time, so you should be really familiar with it, and that's going to be your go-to place for every SQA past paper. You should definitely be attempting the past papers from the last 5 years, but you can go even further than that, and there are past papers available all the way back to around about the year 2001. Your real aim with past papers is to keep going almost until you have seen every mistake that you could make and you know how to avoid it. And that is going to be what makes you really, really, really successful at higher maths, is that you're trying almost every past paper question, you've seen every mistake that you could make, and you know how to avoid them. I'm just going to show you just now, this is the Free Higher Maths website that you should be familiar with. You're just searching for highermaths.co.uk, or you can just search Free Higher Maths, and this is the first thing that comes up. With just a wee bit of scrolling, you'll get down to this big menu here, okay? And these are the key things to look for. The past paper and practice papers are really, really good because that's going to let you attempt a full past paper. Now, that is you being aware that there will be some topics that you're not familiar with. And if you see a question that you don't think you can do, the chances are we can't do it yet, okay? But working through those would be a great starting point for you to start feeling quite confident with the questions that you can do, and that you can do them under the timed conditions of the assessment as well, which is quite important. This section here will take you to the exam worksheets by topic, which means it's all the past paper questions, but they are split up into the topic that they are from. And that should help you if, in particular, you're struggling to spot, can I do this question? Can I not do this question? You can go through all the topics and use your Google Classroom to help you spot what the names of the topics that you've already done are, okay? They will be quite obvious to look at. The other excellent sections are these ones here. Now, the Higher Maths Essential Skills go through, as it says, essential skills from within the course. So those would be things like, for instance, completing the square, specifically from quadratics, using the discriminant, specifically from quadratics, the graphs of derived functions, and so on. And you'll be able to see, particularly if there's things that you've heard your teacher talking about, or you know from your feedback and breakdown, which we'll talk about in a second, that would be good for you to practice, you should go on and practice those questions. The one underneath that, the Essential Skills Exam Practice, gives you from each topic the kind of key skills that always come up in every paper. And if you were to go through and practice those questions, you would be really, really solid on the types of marks that you can pick up throughout each topic, and you're almost guaranteed will come up in every paper. Okay, so I'm going to flick back for 2B6. Okay, so that's past papers, done, big thing. Next thing would be to use your kind of access to Flip Learning and other videos that are available on YouTube. So if you go into the Larbert Maths page, or you just Google LHS Flipped Learning, because that's another place that will come up, okay, you'll be able to see pre-made videos that we have for the entire course. So if there's something that you're really struggling to get to grips with, you should go on and watch those videos, because there's great worked examples, and a lot of your class teachers will be using similar content to that during teaching time in class, which means that it should all look pretty familiar, the way that, like the examples that you've seen before and the way that it's being explained, and it'll maybe just give your brain that wee kickstarter of reminding you of what's already been done. Okay, now also on YouTube, there's a site called, or an account called DLB Maths, and this is someone who has worked through pretty much every SQA past paper as far back as I can remember, okay? It's someone that I used at school, and if you talk to a lot of your maths teachers, most of them, not to name names, Miss Muxud, but if you ask some of your maths teachers, you will have heard them speaking about this person before, because he's done past papers for years and years and years, and he explains them really, really well and where you get the marks from. So if you've done a past paper and you want to know how it would be marked if you're not 100% for yourself from the marking instructions, then please go on and use DLB Maths, just because he breaks it down fantastically and in a way that I think will be really accessible to you guys as well for your own revision. Last but not least, on your Google Classroom, you will have a pile of FAB revision tasks that have already been posted, and that'll include some booklets for you to work on as well as part of your revision, that have been created really painstakingly by the people within the maths faculty, so you should definitely make use of them because they are fantastic. And you should also be making use of your feedback sheets. So those are the kind of breakdowns that you've got from your block 1 and block 2 assessments, and also the kind of learner conversation prompts that are within that as well, where you already have kind of had a discussion with your teacher about what you should be working on. So make sure that you use those, especially any topics that you've got highlighted as red topics in there. Those are the essential skills that you should be going on and practicing and trying to make sure that you can recover some marks for those sections. Okay, that's all that I've got for you for the time being. I hope that you manage to make the most of your holidays and also with your revision as well. All the best of luck, and we'll see you after the holidays. Bye.